Welcome everyone to our lesson on data representation. Today we'll be talking about combined data sets for X and Y. X could be a different observation and then Y could be another observation. Our aim is to explore the concept of combined data sets. Now, at the end of the day, you should be able to do these three things, okay? Recall and write formula, substitute into formula correctly, and then use formula to solve questions. So when we talk about combined data, what are we talking about? What we are talking about is a situation whereby you have two different data sets. Let's say you have a data set for United States, and then you have another data set for the Great Britain, and then you are told to combine these two data to answer a question on the mean or the standard deviation or variance. So this is what combined data is all about. So we have different formulas for combined data. They are different from when you have the single data values. So for combined data, what you are doing is that you have the sigma x plus sigma y, okay, where sigma x is the first observation that you have, the total, and then you have the total of the second observation. Then you divide by the total number of observations for both, okay? That is the observation for the first one plus the observation for the second one. Now, when you take the standard deviation, it follows the general standard deviation formula. Okay, for the single data of standard deviation, we said that is given as, so you have sigma x squared over n minus sigma x over n squared. Okay, it's the same argument that we are making, just that instead of sigma x, we are dealing with more than one value, okay, more than one observation. So we are dealing with both x values and then y values. That's why we have sigma x squared plus the second observation, which is sigma y squared. Then instead of n, we divide by the sum, okay, so the first n plus the second n. Now, you see, we subtract the mean. It's the same argument we are making here, that sigma x, all right, but since there are two observations we are dealing with, we have sigma x plus sigma y. Then instead of we saying divided by n, we are dealing with two observations, so divided by nx and then plus ny. Then we square it. Okay, so that is the formula. If you don't want to write it this long process, you can also write it this way, whereby instead of writing this, you just say the mean square. That's also fine. So I have some examples here. I want to clean this. It's not part of our presentation today, so let me clean it. Okay, so I have two examples actually for us to solve. We want to follow through the example and then be conversant with what is expected of us. So this is the question. The question is, a test is taken by 30 students, right? So 30 students took the test. Their score, now their score is denoted by X. So that is for the 30 students. They have a mean of 60 and then a standard deviation of 20. Now our first job is to find sigma x. Then we should prove or show that sigma x squared is giving us 120,000. So let's start from there. Okay, let's go and solve that one and come back later. So let's write the things that we can work with from this question. We know that n is 30. So that is the number of students is 30. So n equals 30. We also know that the mean is 60. Remember they said x represent their score, so we can say x bar is 60. Then we are told that the standard deviation is 20, so we can just call it SD equals 20. Okay, now they want us to find two things, sigma x, and then we should prove that sigma x squared is 120,000. Okay, so let's start. I. Now, if we want to look for sigma x, we should remember that the mean formula, that's x bar, is sigma x over n. So from this formula, we can find sigma x. We know that the mean is 60, so we have 60. is equal to the sigma x over n. N is 30. This means that sigma x is 30 times 60, giving us 1,800. So we have found the first part. Now the second part said that we should prove. Well, the fact that we have sigma x squared, that means that we are dealing with either the standard deviation or the variance formula. Okay. Now, we were given our standard deviation. We can square it so that we will be working with variance. So we know that the standard deviation square is the value of the variance. Okay, and the variance is given as this. All right. So now we can put the standard deviation there. That's 20 squared. Then we have sigma x squared over n. N is 30 minus the mean. Now we know the mean is 60 from the question. So we have something like this. Now solving for sigma x squared, we have so what do we get? We get 30 into 20 squared plus 60 squared, and that will give us 120,000. Okay, so we have proved it. Now let's go back to the question and look at the other demands of the question. All right, so there is another set of students. Okay, they are 20. They take the test. Now their test score is called Y. So you see, first we are given 30 students. Now there's a separate 20 students. So this is what combined data is about. Now we have true data and we are going to work with it. Now they said that the total sum of their scores is 1,400, and then sigma y square is 100,000. Okay, so let's write this. We know ny is now 20, and then the other information from the question, we can put it down and then work with it. So now let's put those things down. From our previous, let me change the color. From our previous solution, we saw that nx was the number of boys, as those who, the first 30 students. Then we know that the mean, that's the sum of x. We solved it, we got 1,800. Then finally, the sum of x squared was given as this. Okay, now from the new question, the next 20 students are called y. And then the sum of y was given as, let's check that one out, 1,400. And then the sum of y squared was given as 100,000. Okay, now what is the question asking us to do? The first thing that we need to do is to show that the mean of this combined is 64. Okay, so when we solve and we don't get 64, we are wrong. When we solve and we get 64, we are correct. All right, so let's do this. Now, the mean formula, always write the formula first because it will help you to know what you are doing. Okay, this is the mean formula. Now, we also know that sigma x is 1,800, sigma y is 1,400, and now we are dividing by 30 plus 20. And when you put this thing on your calculator, you should get 64 as required. So now we have proved the first part of the question. Now, the second part, that's the second part of the second statement. In other words, the third question says that we should look for the standard deviation of the combined. Okay, that's the 50 students. So let's do that. Let's first write the standard deviation formula. So SD is equal to, this is terrible, the square root of sigma x squared plus sigma y squared over nx plus ny minus the combined mean, okay, and as the combined mean, and then we square it. All right, so this square actually looks terrible. Okay, and now we know what the sum of x squared is. Sum of x squared is 120,000, and then sum of y squared is 100,000. Now nx is 30 plus ny is 20 minus the combined mean. Now the combined mean, we know that the combined mean is 64, so 64 squared. You put this thing on your calculator, ladies and gentlemen, and then your answer should be 4 root 19, or you can write 17.4. That is correct to 3 significant figures. All right, so this is how we go about it. Now there's a second question I want us to solve. It says that the table below shows the mean and the standard deviation of the height of 20 boys and 30 girls. Okay, we should find the mean and the standard deviation of the height of 50 children. That means that it is a combined observation that we are going to work with right now, not the individual. Okay, so let's do some definitions here. We can say that let x represent boys, boys. Okay, so that when we are dealing with x, we know we are talking about the boys. Then we can say that y should represent girls. All right, so this is the first thing that you want to do, so that when you are talking about x and y, the examiner knows what x represents and then what y represents. Okay, all right, so we can say that the first thing is to find the mean. So you just write a formula. It will help you to know what exactly you are dealing with. So the mean is the sum of x plus the sum of y over nx plus ny. Okay, so from the question, we know the mean for the boys, we know the standard deviation, but what we don't know is, we even know the nx. In fact, the number of boys is 20, so we can say nx is 20, and then ny is 30 for the girls. Now, what we don't know is sigma x and then sigma y, so let's go and look for them. All right, so you know that the mean for single data, and this is single because I'm taking the boys first, a single data. So the mean is sigma x over n. So it means that sigma x is actually n into bracket x bar. And I know that the n for the boys, or let me just call it nx, for the boys is 20. And then from the table, the mean for the boys is 160. So I can now say that when you multiply the 20 by the 160, you should get 3,200. Now I'm going to do the same thing for the girls. I'll call that one the sigma y. So sigma y will be equal to ny times x bar, not x bar, y bar. The girls are y bar. Okay, so that will be 30 times the mean for the girls is 155. Now let me grab my calculator and check this one real quick. Okay, so you have 4650. All right, so we can now say that our mean will be equal to sigma x will be 3,200 plus sigma y, which is 4650, all over nx plus ny, that's 20 plus 30. Now when you check this thing with the calculator, you should get 157. So that is the mean. The next thing that we need to find is the standard deviation. Okay, we have to find the standard deviation. Like I always say, it's best to write the formula. So standard deviation is equal to the square root of sigma x squared plus sigma y squared over nx plus ny minus the mean, and the mean is sigma x plus sigma y over nx plus ny all squared. Okay, now we do know the mean. Okay, we know what this mean is. We know it's 157. We know nx, we know ny. What we don't know is sigma x squared and then sigma y squared. So now this is what I want us to do. I want us to pick the boys first. All right, we said the boys is x. So we can say that for the boys, okay, for the boys. For we know the table gave us the standard deviation, so we can work with the boys standard deviation, and then we can find the sigma x squared. All right, so let me make this thing smaller like this, so I wouldn't be moving up and down rough. Okay, so the standard deviation square is sigma x squared over n minus the mean, okay, for the single data, that's sigma x over n. Now from the table, we know for the boys that the mean is 160, the standard deviation is 4, and then the number of boys is 20. So we can just substitute. Standard deviation is 4, n is 20, and then the mean was given as, let me check again, 160. Okay. All right, so what this means is that if you make sigma x squared the subject, you are getting 20 into bracket 4 square plus 160 square, and this will give you 512320. Now for the girls, we said the girls is y. So since we are using y, we are going to use the same argument that we use for the boys to find the sigma x squared. So we are going to use the same thing for the y squared. That means that we need the girls, their mean, their standard deviation, and the number of girls. So the mean is 155, standard deviation is 3.5, and then the number of girls is 30. So let's go and do it. Now we are going to square the standard deviation. Okay, the standard deviation of the girls was given as 3.5. So you have 3.5 squared is equal to sigma y squared over the number of girls, 30, minus the mean, which is 155 squared. Okay, so if we make sigma y squared the subject, then what we are getting is 30 into bracket 3.5 square plus 155 square. And ladies and gentlemen, this will give you 72111.7.5. Okay, so now we know that the standard deviation formula says that the sum of x squared, so we will write that one first, 512320, plus the sum of y squared, which is 72117.5, all over nx. Nx was 20 plus ny, which is 30, minus the mean. But remember that the mean that we solved was 157. So minus the mean, which is the combined mean. Don't go and add the girls' mean. Okay, don't go and do this. What is it? The girls' mean plus the boys' mean. Don't do that. Okay, that is a waste of time. Okay, so now let's put everything on the calculator and then evaluate. When you do that, what you are getting, this is squared, right? What you are getting is 4.444. But in your A-level mathematics or statistics, your answer is always correct to 3 significant figures unless the question is telling you to do otherwise. So we have to round this to 3 significant figures, and this will be our answer. All right. So this is how to go about it. If you are given a table, you should just write out the important information from the table and then work with it. If you are given a word problem, extract the important information and work with it. So this is what combined data is all about.